Hey, what's up guys? Welcome to the developer. This is Ayush, and today in this video we'll be going over this state machine. Well, not this state machine in particular, but the animator controller. We'll be going over how the Unity's animator controller state machine makes the animation and transition between these different states happen, and how this makes your player and your game come alive. So without wasting any further time, let's get into it. Okay. So I have set up this demo game dummy environment. Well, if you look in the scene view, this is how it looks like. I have used free assets from the Unity asset stores, everything from the background to the platform as well as the player. Everything is available on the Unity asset store for free. I'll put up a link in the description to these free assets if you want to check them out. And let's first of all see what this demo scene looks like. So I'll play it maximized. Okay, so this is our player, and we can use the left and right arrow keys to move forward and backwards. So we can also press the left shift key while we are moving to make the player run. We can press the space bar at any time to make the player jump. You can also press the space bar while the player is moving. And we have a few combat moves, like if you press the left mouse button, the player will perform a left hook. If you press the right mouse button, the player will perform a right hook. If you press the middle mouse button, the player will perform an uppercut. If you press the left control key on your keyboard, the player will kick. Play these in combination and this all looks really cool. So we have a few things over here, and at the bottom you can see is the state machine for this player's animation state. So there are a lot of states and a lot of transitions, and this constitutes the animation state machine for this player. Well, um, let's get to seeing what all the animation clips we have on our player. So we have player idle, player jump, kick, left punch, right punch for the left hook and the right hook, running, uppercut, and simple walking. You already saw how these clips look like while I play tested the game. You can also see how it looks like if you click on the play button while any animation is selected. Let's hit play. This is the idle animation. This is the left punch. This is the uppercut, right punch, and so on. Well, let's get into the logic, shall we? How do these transitions happen? How these transitions are taking place? So, if we look at the very right of our screen, we have this inspector tab. Here in the inspector tab, we have this expandable and collapsible sections right here. Transform, sprite renderer, not the additional settings, it's a subheading under the sprite renderer, box collider 2D, rigid body 2D, the animator, the thing which we are most concerned about in this video, and the movement script. Let's give a brief introduction about what all these things are doing over here. Different expandable and collapsible sections are called components. These components are attached onto the player game object. Everything which you see inside of your sample scene, all of these things, main camera, background, this whole tree hierarchy is constituted of game objects. These are all essentially game objects. Every game object can have a number of components, any number of components attached to them. This is how the typical Unity flow goes on. So here you see our player has transform components, sprite renderer component, box collider, rigid body 2D, and so on and so forth. We can attach our custom created manual C# scripts to these players or these game objects in general to control their behavior and to hook in some actions. Like for example, if you want the player to be jumping when you press space, then That can be done by controlling the player movement when you detect the user pressing the button spacebar. Pretty intuitive. But you capture all these events in a script. That is where C# scripting comes into picture. Let's head on to the movement script which I wrote to see how it looks like and how it is controlling the player behavior. Let's double click on it to open it into Visual Studio. Yeah, every script which is attached to a game object in this Unity scene should extend or should inherit from the MonoBehavior class. The MonoBehavior class is a class which exposes some methods like start, update, and apart from these, awake and a few others. Well, we don't need to get into the actual details of these methods. Just the description over here is enough. This description over here, which is on line number 11 and line number 20, is automatically written by Unity when you create a new script. This is the boilerplate code. Not exactly this, but something like just an empty start method, an empty update method, and this comment over here. The rest of the things we need to add on our own, and based on your function of the script, what you want to do in the script, you pretty much go on with it. So let's think what we wanted to do over here. So what we want with this script, when the user presses some buttons like arrow keys, space bar, left control, left mouse button, right mouse button, middle mouse button, so on and so forth. And this we can do by gathering the inputs and also changing the animation state, because we just don't want to make the player move. We also want him to show some animation clips. The clips which we saw in the animation tab. These clips. We want to switch between these clips, and we want that to happen through this animator controller directed graph, this state machine. We want that to happen through this and play every clip whenever the situation for it arises. So, okay, before we go ahead, I just realized that I missed informing you all that how this thing, this node, this player jump, for example, plays the animation clip. It doesn't know what clip to play actually. We may inform what clip to play for this state over here. So in the right section in the inspector tab again, you see motion. We have selected player jump clip. What player jump clip looks like? Player jump clip looks like this. So this is the clip which would be played when the player jumps. Couple it with some transforms to move the player up and down, and you have got a lively player. All of this we can do with the help of this movement script. Let's head on to our movement script back again to see how all of this is coming into picture. We have our private animator variable, rigid body 2D, and sprite renderer. These are all private members. We don't need to expose them anywhere. Animator, rigid body 2D, sprite renderer, all of these things are, if you take a note, components attached to this player object itself. So we can use the get component method provided by Unity to grab these objects into our script. That's what we do at the very start of our game. Whenever the script initializes, that would happen whenever the player object comes in the scene. So this player can be instantiated by any other script also, but for simplicity we will assume that our game from the very start has the player, and it gets instantiated by default by Unity. Every object in the scene which you see are getting instantiated by default by Unity at the start of the scene. Okay, so this start method is guaranteed to be called at the start of my game, and that's when I want all the animator, rigid body 2D, sprite renderer, and is jumping variables, my class member variables, to be initialized. Okay, so the animator is get component animator, follow the same trend, rigid body 2D, and sprite renderer. Is jumping is for controlling certain behaviors, not only jumping, but we'll see how it controls walking and running too. Well, that is how we are going to be controlling our player. So we're just keeping this to not complicate our logic too much, even though it can be simplified further, but for purposes of this video, I have made it like without any kind of over optimizations, keeping it really simple. So let's go. Update. Update is called once per frame. So when the game runs, the game engine spews out frames, a number of frames actually every second. So that's the FPS of the game, 30 frames per second, 60 frames per second, depending on your um, game configurations. This can vary, the platform which you're running it on. It might vary, but this method is guaranteed to be called once every frame. So if the game is running at 30 frames per second, this method will be called 30 times in 1 second. So we need to be cautious with this method and should refrain from performing high computation tasks in this method. Uh, so let's see what we are doing here. In update, we are calling handle input, just one method. However, this method is kind of big. It goes on from line number 27 to line number 128. But all we are doing here is just if else and changing animation states. We are not doing any kind of high computations, calling recursively any functions, doing any loop or whatever. This is pretty much basically following just one, two, at most 4 or 5 lines per frame, setting some values, reading some values, changing some animation states, which are not that high computational expensive. Well, if you want to over optimize, animator.setPool is walking false, like these kind of instructions. They can be cached, but I'm not going into that for this video. We start breaking this down. Okay, if rb2d.velocity.y less than 0.1. Well, your player's velocity is something which will be stored within the rigid body 2D component which you see over here. This rigid body 2D component which is applied onto this player game object will be controlling what velocity this player has. This will be updated automatically as the player moves, but you can also set it for some certain kind of jerky or abrupt motions. So for example, if the player gets hit, you want the player to be moving in the opposite direction or in the direction in which he was hit, uh, with some certain velocity, or you just want to give an impulsive force in the direction like 10 newtons or whatever, and the play velocity, acceleration, all of that would be automatically handled by this rigid body 2D component. We are not going into that deep of a discussion in here. We are keeping things simple, as I am reiterating again and again. So we are just checking if the rigid body velocity, so this velocity is a vector 2, it's a vec2, and it has two components, x and y. We are just checking if the y component falls below 0.1, then we set the variable is jumping to false. So pretty intuitive. You jump in the y direction. Y is the direction uh, from top to bottom, bottom to top. So if the velocity in the direction of that player becomes less than 0.1, then we want to set is jumping to false. Else we want to set walking to false, running to false, and is jumping to true. So first of all, we want to set is jumping to true. Then next thing, we don't want to be showing the walking and the running animations while the player is jumping. That is why we set is walking and is running to be false. This is how in the animator which you see over here, you set the value of these parameters. These parameters are the one responsible for controlling the transition between these states. If I look into one of the transition states, like we look into player idle to player jump transition, this edge right here, this one has a condition. This transition will only happen if is jumping is set to true. So whenever we set is jumping to true, the player will start performing the jump animation and will stop performing the idle animation. When we look at this transition from player jump to player idle, when the variable is jumping is set to false, the player starts performing the idle animation and no longer performs the jump animation. So that's pretty much it. For player run is running true. When player stops running, then we want to set is running as well as is walking to false, because now the destination state is player idle. When we are idle, then we aren't running neither walking, so is running and is walking are set to false. Well, pretty natural, pretty intuitive. Once again, now player idle to player walk. If we look at this edge right here, is walking is set to true. Whenever is walking is set to true, well, anyone can set it to true. Preferably the movement script which we have, we will want to be setting it true from within that script. So player idle to player walk transition will be controlled by the movement script when it sets is walking variable to true. Is walking is a variable which will be contained within the animator controller, and we have already grabbed a hold of that animator controller instance over here when we take in the reference to the animator. This animator actually is the animator component attached to this game object, but it has this controller, and calling these set bool and set float or whatever methods on the animator will in turn set these parameter values in the animator controller. Now let's for once play this while focused and try to notice how we move across all these animation states. So I will increase the scale a bit. So now with our players selected, we can see how the different animation states are getting triggered. If I press the left mouse button, the player left punch state, we transition into that, and that animation completes, we move to the idle state. Similar for the right hook, uppercut, as well as the kicks. Let's have a look at motion. So when we walk, the player walk state is activated. As soon as I press the left shift key, we move on to the player run state. I stop pressing the left shift key, we are starting to walk. If I stop pressing the left arrow key, we are again in the player idle state. If I press jump, I move on to the player jump state. And as soon as my jump terminates, I land and I am on player idle state. I can walk. Now I can also jump. While I jump, the player walk animation gets disabled. We can also do this while running. It will increase the speed at which you jump and move ahead. Now we want to see if the player is not jumping, only then we want to enable the running or disable the running and walking animations. If the player is not jumping, which means he is on the ground and the user has pressed both the right arrow key as well as the left shift key, we want animator to be switching into the running state. Well, means setting the is running variable or is the running parameter value on the animator to true. We also want to be setting is walking to false, because now the player is running, left shift key is pressed. However, if the left shift key is not pressed, we want to set the velocity to a lower value. In this case 2, not 5. The y velocity goes on to be controlled by the rigid body 2D component, and we want the same thing again. However, we want to be setting running to false and walking to true. Same thing in the sense, we don't want to be setting this if we are jumping. We only want to be setting this if we are grounded. So is jumping variable is not only helping us in controlling us in air, but also controlling us on land. Well, that's it for the movement part in the positive x direction. Let's get on with the movement in negative x direction. When the player moves towards the left, not only want the player's x component to decrease, go towards negative values as the player moves towards the left, but we also want that the sprite, the picture, the small tiny little picture which is getting rendered to represent the player, that gets inverted. That's what is happening. So if we play the game again and we see as we move towards the left, the sprite inverted. The player is heading towards the left direction. As we move towards the right, the sprite inverts from the left towards the right. So this is a very crucial aspect, and we will see if we disable this feature what happens then. To give you an idea of how important or how disastrous can this one single line be, let's skip this for now. We'll get to it when we try enabling and disabling it. The rest of the things are pretty much the same. We are doing the exact same drill, however we're moving towards the negative x direction, so we are setting this value to be -5 and here -2. These lines are exactly the same, no change at all. Now if none of the left or the right arrow keys are pressed, we want to say that my player is neither running nor walking nor jumping. Well, he might be jumping because in idle state also the player can press the space bar and he might jump. So we want to keep the y velocity controlled by the rigid body 2D component. We just give some impulses and rigid body 2D will automatically compute the y velocity, do this physics calculation internally. We don't need to worry about it. We just want to set the running and walking parameters of the animation controller to false. Down here we initiate the jump. So if the input.get key down key code space returns true, if this piece of instruction or function call returns true and we are not already jumping. So this is also very important because double jumping is against physics. You can't jump while you are in air. I mean, you already jumped once. You can't jump while you are in air. So to make sense of that, we have added this not is jumping condition. Now, if this holds true, this compound statement holds true, then we use rigid body 2D to add some force in the positive y direction and give the type of force to be an impulsive force, and we set is jumping to true. We don't need to do this because this is redundant anyways, as this instruction, this update method gets called every frame. If we are setting it to true, the movement script retains the state information, and at the top over here we are anyways setting the animator controller's is jumping parameter value to is jumping of our movement script. So don't need to be setting it over here. We don't need to set the bool over here. We can skip this part. I'll go ahead and delete it. It's basically not required since the next frame we are going to be changing the state anyways. Well, it would be good if you change it. Doesn't matter because this is getting called every frame. Okay, now these things right here are same drill following the same pattern. All of these variables over here which you see, left hook, right hook, kick, uppercut, these are all trigger variables. All of these are getting set in the same way. We just handle the different control, the different key inputs, the different mouse clicks and all. So for left mouse button it is 0, right mouse button it is 1, middle mouse button it is 2. So we just call Unity input class methods to identify if left mouse button is pressed in this way, and we set the animator trigger. It is how it is getting handled. Since this is not a Unity tutorial, it's not an animation tutorial, it's just how state machines are going to be beneficial in game development, how these things make your player come alive. It was just a demonstration for that, so I'm not going to give you the explanation of what the different kinds of animation parameters, animation controller parameters rather are, what these do. This might be covered in some future video. Let me know in the comments if you need that. That was it for this video. Well, before ending this video, let's quickly go over the part which we were discussing earlier, and I said that I'll get back to it. This is the sprite renderer flip X. So if we are moving towards the left and if we don't flip the sprite, let me comment this out. Let me okay, now once that is commented out, let's go back to our game and run it. Okay, now we are in our game. We move towards the right. Now see what happens when we try to move towards the left. Okay, this is not right. This clearly is not right. There's something wrong. What is wrong with it? Well, we are not flipping the sprite. If we start flipping the sprite, we no longer will face this issue. So this little detail right here makes our game from obnoxious to playable to interesting. Now, this is true. Now, why do we set this? Okay, so as I said, this update method is going to be called every frame. If you have set the sprite renderer state variable flip x to be true, it will continue flipping x in the next frame. This will seep into the next frame as well. If the player is no longer pressing the left arrow key in the current frame, you don't want to continue flipping x for the sprite. You want that to stop happening. So let's comment this out as well and see how this small little detail also is an element of importance for our game. If I go back to Unity, play, okay, everything is fine. We are moving towards the right. Now we are moving towards left, still fine. Okay, what happens if we move towards the right now? Oh damn. Since we didn't start unflipping the sprite in the X direction, this again causes an issue in the user experience. The players won't like our games. So we need to disable flipping X back again when the right arrow key is pressed. This makes our game consistent and helps keep the player experience alive. So that was it for this video. Um, that was how the Unity's animation controller has this state machine, how it works, how it is used to create player animations, and how can it quickly bring the user experience from 0 to 100. Use it carefully because a mix of parameters make it too complicated and it is going to go beyond your head. You might miss certain things, you might not want certain things to happen and then they are happening, and debugging it will take you a lot of time. So yeah, that was it for this video. Let me know in the comment section if you have any suggestions, if you have any new topics, if you wanted something more out of this video. I'll be putting the links to these assets which I have used for my demo in the description of this video. Thanks for watching. See you later. Bye bye.